So we're working with our double angle identities. Excuse me, half angle identities, not double angle identities. And we're going to discuss first this plus minus. Okay, for every sine a over 2, there should only be one number there. It's either positive or it's negative. It's not both. And here's a couple of problems to help you practice with that. Here it says, okay, decide whether the positive or negative square root should be selected. How the heck do we decide on that? Well, you look at this angle right here. 36 degrees. 36 degrees is in which quadrant? It's in quadrant 1. In quadrant 1, is sine positive or negative? Positive. So the sign that you're going to choose, the SIGN sign, is the one that has the plus there. Did both of these regenerate to be negative? I think number 2 is going to have the same answer. Darn. Tangent 30 degrees. That's in quadrant 1. Tangent in 30 degrees is positive. So wow. Don't decide, okay, he's saying that it's always going to be a positive square root. No, it isn't. Let's write out, let's suppose we were doing tangent, 100. Tangent 122.5. Okay. Yes, you're right. It's negative. But if I write it out with plus minus, and then I'm thinking that this 122.5 is what number over 2? What's 2 times 122.5? Is it... So what's 122.5? Is it 245? What's 122.5 times 2? Is it 245? Someone with a calculator? My brain is not working very well today.
That's right.
245 divided by 2 is 125. Ooh, y'all can't see that, but it works nice on. It's the projector it looks bad on. When you see it on YouTube or whatever, it looks great. Okay, 122.5. So if I'm thinking of 122.5 is 245 over 2, this would be 1 minus cosine 245 over 1 plus cosine 245, I don't have my little degrees. And so the question is positive or negative? Which one is it? And Jerry's already answered. What is it? You look at this angle, 122.5, that's in quadrant 2. In quadrant 2, tangent is what? Positive or negative? It's negative. Tangent is negative in quadrant 2. So, oh yeah. So, I was about to say I marked the wrong answer, but no, I made up this one. It's a negative square root. Okay? You're looking at the sine SIGN in that quadrant. Okay, in quadrant 2, the sine of the tangent curve or tangent function, sine over cosine, is negative. Any questions how I figure out that plus or minus? Because now we're going to do a problem like this in its entirety. Okay. do problem number. Oh, well, I guess I can cover it. Oh, wait. Are y'all finished with this? Oh, going to. Now, on number 3, okay, it says find the exact value of sine pi over 8. Well, sometimes students say, oh, I can do this easier if it's degree measure. So, okay, let's think of it as degrees. 180 degrees divided by 8, is that not 200, is that 22.5? 180 divided by 8 is 22.5. So that would be, how would I write it as over 2? Well, you multiply 22.5 times 2, and that would be what? 45 degrees? So I'm rewriting 22.5 as 45 degrees over 2. And here's that half angle identity for sine. Go through and replace the A with what? 45, that's right. You're thinking of the, this is A over 2, so it's going to be plus or minus the square root of 1 minus cosine 45 degrees all over 2. And I don't know why I wrote the plus minus. I think we could go ahead and decide right now, is it a positive square root or a negative? It's positive, because we're in 22.5 would sure be in quadrant 1. And in quadrant 1, all the trig functions are positive. So that's not a star I just made. I crossed out the minus. So let's see, how are we going to simplify this? Well, what's cosine 45 degrees? Yeah, that's square root of 2 over 2. So I'm going to rewrite this, replacing cosine 45 degrees with square root of 2 over 2. And we still have this all over a red 2 there. So the natural question is, how the heck do we simplify this? Well, I can get rid of this 2 right here, the blue 2, by multiplying above and below by what? 2. It's going to really work out nice now. Well, not nice. Well, it could be worse. When I do that, on the bottom, what do I have? A 4. Now on the top, distribute that 2. The 1 times 2 is 2. The 2 square root of 2 over 2 times 2, there the 2's cancel. Any questions on that, how I got that square root of 2 minus the square root of 2 all over 4? And then finally, if you look, none of those answers are them, but there's one thing we could do. This bottom thing right here, the square root of 4, we can actually calculate that square root. The square root of 4 is 2. And so we only have a square root. Well, this purple square root doesn't go down to the bottom. So it'll look better written all in one color. Which one is it? A, B, C, or D? It is C. Now, any questions there? You'll see how I did that. The 45? Well, I'm just thinking of 225 degrees as something over 2. And so how do I figure out that number up there? Well, I multiply. How do I get the 45? I multiplied 225 times 2. Okay? And I got that hint, sort of, or idea, sort of like looking at this one over here. tangent 30 degrees. Notice the angle they're using is 60. It's just whatever this number is times 2. And the same thing right here, the 36 degrees times 2, 72. Okay? On number 4, let's write it as an over 2 angle. What over 2? How do I figure out that number here? That goes up on top. Ooh. You multiply the 112.5 times 2. That's 112.5 times 2. 225. So how did I get the 225? I multiplied that angle by 2. And now, why am I writing it as over 2? So it'll be in that over 2 format. Where did I write those half angles identities for tangent? Okay. Right here, there are, ooh. Let me do it like this. There. Clear away all this mess. And now let me move it so y'all can see. There. Which one of these, you have a choice now. You're going to go in and replace the A with 225 degrees. And which one of these do y'all want to use? You can use the plus minus square root, or sine A over 1 plus cosine A, or 1 minus cosine A over sine A. It's up to you. I think I'm going to not use the plus minus square root one, okay? I would use one of these 2 red ones. I'm thinking those might be easier. Maybe I'm wrong. I think I'm going to use the 1 minus cosine A over sine A. 1 minus cosine A over sine A. I'm plugging a 225 in for these. And I see Catherine looking at a unit circle, so do you want to help us out? Cosine 225 degrees is?
Negative square root 2.
Uh-huh. While sine 225 degrees is? Same thing. Negative square root of 2 over 2. So I'll replace cosine 225 degrees with negative square root of 2 over 2. I'll replace sine 225 degrees with negative square root of 2 over 2. Oh, and how do we go about simplifying this? Well, this minus and negative right here I'll write as plus. And then we still have a negative square root of 2 over 2. And wondering, do I want to break this up into a couple of pieces or do this all in one big step? Well, I could multiply above and below by 2, and that'll get this 2, the 2's here to cancel. We would have 2 plus square root of 2 all over, is that a negative square root of 2? And it's going to simplify down to one of these answers here. So what can I do to simplify it now? Well, move it up. Not too much. Well, I'm just going to break these up. So we have negative 2 over the square root of 2, then a minus square root of 2 over square root of 2. This minus here became a minus because of positive over negative. So this square root of 2 over square root of 2, that's easy to simplify. So 1 and a minus in front. But this negative 2 over the square root of 2, could y'all rationalize that? What would we have? If we have negative 2 over the square root of 2, you would rationalize by multiplying above and below by square root of 2. It's going to simplify pretty nice, isn't it? What would all of this stuff simplify to? We'd have negative 2 square root of 2 all over 2 minus 1. Cancel those 2's. Hopefully this is one of our options. Negative square root of 2 minus 1. Is it, well, it's written with the 1 first, but it's that one there. Negative 1 minus the square root of 2. Y'all follow that simplification? It's sort of messy, isn't it? Okay. Any questions over that? These half angle identities can look a little intimidating at first glance. Are we ready to try another one like that? Number 5. Sine pi over 12. Well, what do you think everyone wants to do? They want to convert that pi over 12 to degrees, and I can't blame you. Thinking of pi as 180 degrees. 180 degrees divided by 12, 15 degrees. See, there's not a 15 degrees labeled on the unit circle, is there? We've already seen one way you could get an exact value, and that would be maybe rewrite the 15 degrees as 45 minus what? 30. I think that's probably the easier way to go about it, but here's one way you could do it. If you want to use a half angle identity, you could rewrite this 15 degrees as what number over 2? 30. And remember, sinus minus, this is the one that has the minus in front. Excuse me, not in front. Under the square root. So, you know what? I'm going to write the identity I'm using right up here. Sine A over 2 equals plus or minus 1. Now, is it minus or plus? That's where I think, oh, sinus minus. Minus cosine A all over 2. Now let's go ahead and decide between positive or negative. We're in which quadrant? 1. So is it going to be positive square root or negative? Positive. Sine's positive in quadrant 1. All the trig functions are. So I'm going to say 1 minus cosine, what am I going to put in place of the A? 30 degrees all over 2 1 minus, Catherine's looking at her unit circle, cosine 30 degrees is square root of 3 over 2. So this is another one. Hey, it seems similar to one we've already done, doesn't it? What could I multiply above and below by? Okay, if I multiply above and below by 2, that's going to give me just a 4 in the bottom. And that's nice because the square root of 4 is 2. But what about the top? We would have 2 minus square root of 3. And now I'm actually going to say, okay, the square root of that bottom number, the square root of 4 is 2. And now the square root is only on the stuff on top. Square root of 2 minus the square root of 3 all over 2. I think it gives you a nicer form if you had done 45 degrees minus 30 degrees. Oh. Oh, wait. All right. Okay. Okay. Can y'all see that?